Yeah, so hello everyone. So today we would be basically solving the first three questions of the last code forces round, that is Div 2 questions. So we will start with first problem, that is max plus size. So first of all, let's try to understand what the problem is saying to us. So here we are given with an array where each of its elements are represented as a1, a2, an. Basically, the first number is represented by a1, second is represented by a2, and ith number is represented by ai, like that. Here we are given that we can color the elements in red, but there cannot be two adjacent red element. Means that if I am coloring, let's say, ith index with red color, I can't color I minus 1th index with red color and I plus 1th index with red color. So it basically says that adjacent element can't have red color at the same time. And here we are required to find the maximum value of red elements plus the number of red elements. So basically, the after coloring the array, we can have a score for that array. And how we will calculate the score? That score will be calculated by calculating the number of elements that we have colored with the red color and the maximum of that elements which are colored in red. So adding the count of red elements plus that maximum will get me the score of that array. So we are required to find the maximum score that we can get by coloring the array. So let's now jump on to the solution, how we would be solving that. Let's go to the of now. So let's see how can we solve that. For an example, let's assume we are given with let's say five elements, and I assume that we have five elements as one, two, three. Sorry, let's take different color. One, two, three, four, five. Now let's assume we are coloring the element. So there is, if there are n elements, I think if let's assume if there are n elements, so there is a possibility that n could be a even number or it could be a odd number. So if there are so what would we have to maximize the score for the array. So it would be optimal to color alternate elements. Like if there is are five elements, so we have two options. We can color the first element, third element, and fifth element. Yeah, so I was telling that if there are n element, it is optimal to color alternative element. Then we can color at most element that we have in the array. Like if there are n elements, and say if n is even, so we can choose like index in alternating fashion. Like if I am coloring the first element, then I can color the third element, then I can color the fifth element, and other option I will be having is I can color the second element, then fourth, then sixth, in this fashion. So we have only two choices of coloring the element. Then we can get the number of elements colored in the array as maximum. And now if I choose this two differentially and check the score according to these two options differently, we can get two different scores, and out of them, one of them will be the maximum, and that would be the answer. So how I get that answer? Instant that say one of the element in the array is maximum. So when I am coloring the array in alternating fashion, then one of the options would be containing that maximum element, and adding the number of elements colored in red will get me the score that would be the maximum score. So if I check that which of the two options get me the maximum score, that will give me the answer. Let's see for this example. If I color if I choose option one, I can color the first element, then third element, then fifth element. And if I calculate the score according to this, so score of option one will get me that I have colored 3 elements, so it will be 3, and max of the red elements is 5, so it will give me score of 8. And if I color it differently, like using second option, then I can color it in this way. Then score according to the option 2 will be 2 elements I have colored in red, and the maximum of the elements colored in red is 4, so it will get me answer at 6, and maximum of these two is 8, so this would be my answer. Now if I check any other way of coloring the elements, like if I choose a different way of coloring, like choosing the maximum element and then coloring the element according to that, will give me coloring in this fashion. So if you see, this is equal to the option 1. So checking the two options that is met by the alternating fashion will always get me the maximum score. So this could be my approach to solve this problem. Let's take one more example uh, from the inputs given. Okay, so now you can see the next example. There are 9 elements. So if I there are 9 elements, and if I take bigger, 70, 89, 92, 42, 29, 92, 14, 17, 45. So there are two fashion of coloring this array again. So choosing option 1, the array would be colored like this, and answer according to this score according to this option will give me, there are 5 elements colored in red, so 5 plus the maximum of the elements colored in red is 92, so it would give me 92, and the answer would be 97 according to the option 1. But if I choose option 2 now, then I can color this in this fashion, coloring second element, fourth element, sixth element, and eighth element. So it would be colored like this. Then score according to the option 2 will be, so there are 4 elements colored in red, so 4 plus maximum of the 4 elements is 92, so it would give me 96, and the maximum of these two is 97, so this will be the final answer. So taking this example also gives an instance that not every time taking the maximum element would give me the answer. As you can see that in the both option, we have got the maximum element as 92. So if I say that you would be checking the array and getting the maximum element out of the array, so it might be the case that you choose this 192 as your maximum element and color the whole array according to this element, and then you would get the answer as 96, but the actual answer can be get as 97. So it is better to choose from the scores that we can get from the option 1 and option 2. So this would be the approach to solve the uh, first question. Yeah, so let's move on to the second question, that is all pair segment. So what we are given here, that you are given endpoints on the x-axis at increasing positive integer coordinates x1 greater than x2 and so on. So it basically says that we would be given x we would be given points on the x-axis, that is endpoints, and the points would be given in the increasing fashion. Like for every point would be greater than the preceding one. So and for each pair ij, where I is in between n and j is in between 1 and n, and j is always greater than I, you draw the segment xi to xj. That you would be knowing line segment. So from xi point, we would be drawing a line segment till xj point. The segments are closed. That is, a segment is closed bracket AB. That means for each segment, like if I am starting a segment from xi point and ending it at xj point, xi and xj are also included in that segment. That is what it means from the segment is closed. Now you are given q queries. In the ith query, you are given a positive integer ki, and you have to determine how many points with integer coordinates are contained in exactly ki segments. So after drawing each segment, we are given with some q number of queries, and each query is given with an integer ki, and we need to determine how many integer point on the x-axis are exactly contained in only k segments. Uh, and if there are no points that are exactly contained in k segments, we would give the answer 0. Now let's move on to the example. Let's take a short example first. That I can take the second example here to explain you better. Yeah, let's take a general example first. We are given with a x-axis. Let's say this is 0 and it is going to minus infinity, and this is going to positive infinity. Let's say there are points on this. Let's say we are given some points. Say we are taking 4 points, assuming this one is x1, this one is x2, this one is x3, and this one is x4. Then how we are drawing the segments? So there is a segment from xith element to xj, where I is contained in between 1 and n. Here we have n equal to 4, as we are taking only 4 points on the x-axis, and j is also contained in 1 and n. And after that, I is lesser than j. They can't be equal, and also I will be less than j. Now taking, let's say we take I as 1 and j as 2, then the line segment will be drawn as x1 to x2. So as this would be the line segment. Now taking I as 1 and j as 3, then the line segment will be drawn as x1 to x3. If I take I as equal to 1 and j as equal to 4, then line segment will be drawn as x1 to x4. And other segments I can draw like x2 to x3, and then x3 to x4, x2 to x4, and last segment will be x3 to x4. So these are total number of segments that can be drawn when there are 4 points, and 4 points as x1, x2, x3, and x4. So if I check for any point, like how many segments, like if I consider any point on the x-axis, is there I need to check if is there any way I can get how many segments that point is contained in. So if I take, say I take a point randomly here, can I check if there is can I check how many segments it is contained in? So it is obvious that it is contained in 0 segments, because it is lesser than x1. And if I check for any element that is greater than x4, then it is also contained in 0 segments. So for any point that is lesser than x1, and for any point that is greater than x4, it will be contained in 0 segments. Now let's consider for the points that is like the points that are given in the array. Let's say that is x1, x2, x3, x4. So we need to check how many segments will these points will be contained in. So if you remember from permutation and combination, then you would get it easily. Like if I check for say third element, that is x3, so it will be contained in any segment that will be starting from its left side and will be ending at the right side of it. So for this, we can say for every point that is on the left side of the x3, we can uh, draw line segments to the right side points. Let's say number of points that are on the left side of x3 is say a, and that are on the right side are b. So for every a points on the left side, we can draw b number of line segments that will be ending on the right side. So from permutation and combination, you would be knowing that the total number of line segment that we would be giving we would be uh, that we would get is a into b. So and now there are also the point x3 is also contained in the line segment that are starting from x3 or ending at x3. So number of line segments that are ending at x3 is a, because all the left points from the x3 that are a points can draw a line segments which would end at x3, and from x3, starting at x3, we can draw b line segment that would end on the right side, that are b points on the right side. So b line segments would be there, which would start at x3 and end at any right side point. So for any point on the line segment that is given in the array, we can calculate the number of segments that is contained in by using this formula. Now let's check for the points that are not on the that is not in the array, but it is in between the x1 and also xn, here x4. So let's say there is a point in between x2 and x3. So for this point, it would be contained in the line segment that is starting at the left side and ending at the right side. So let's say for this point, there are c number of points that are on the left side and d number of points that are on the right side. So for this point, we can calculate that each c point on the left side will draw d line segment on the right side points, and in these segments, this point will be contained in. So simply we can get c into d line segments for this point. Now if we carefully observe, we can get that for every integer point in between, sorry, so we can easily get that for every integer point in between x2 and x3, we will get the same answer, c into d. So for every element in between x2 and x3, we can store that it will be contained in c into d points. Now for this question, it is given that the point x1, x2, and x3, x1 like x points can be of order 1e9. So it won't be feasible to calculate for every point that how many line segment it would be contained in. So it is better to solve for intervals. Like for here, what we can do, we can calculate for x1, then we can calculate for all points contained in between x1 and x2, then we can calculate for x2, then we will calculate for x2 for all the points in between x2 and x3, then we will calculate for x3. So in this fashion, it will take O of n time, and we can store it in a map where what we will do in map, we will store we will if you know the map, then there are key value pair. So what we will do, we will take key as the number of line segment and value as number of points. So like for each point in between x2 and x3, let's say there are some m number of points, then we will store map of c into d is equal to m, and in one loop we will calculate the whole we will traverse whole array and calculate for each point how many segments it is contained in, and then we will store it in the map. And whenever in the ith query we will be asked for k, some value k, we will check if this value k is contained in map. If this is contained in map, then we will print map of k, else we will print 0 as the answer. So this is how this problem will be solved. Satyam, बंद करें. Yeah, so let's move on the third problem, that is cards partition. So here we have been given some cards. An integer between 1 and n is written on each card. So basically we are given a number n, and on each card there is a number written between 1 and n. And for each I from 1 to n, you have AI cards, which have the number I written on them. So basically for every type of n card, we are given with AI number of cards for a specific type. Like for a card written with number I, there are AI cards. There is also a shop which contains unlimited card of each type. You have K coin, so you can buy at most K new cards in total, and the cards you buy can contain any integer between 1 and n inclusive. Uh, okay, so there is a shop, and you have been given with K coins. So and every card here cost you 1 coin. So you can buy at most K new cards, and you the card you buy will be of any integer written between 1 to n. After buying the new card, you must partition all your cards into decks according to the following rules. All the decks must have the same size. There are no pair of cards with the same value in the same deck. Find the maximum possible size of the deck after buying cards and partitioning them optimally. So what we are here given with, like after buying cards, or you cannot buy any card, what we have to do, we have to divide total cards into some decks of some size, let's say s. So what here we are given that all the decks must have the same size, so we have to divide the whole number of cards in decks such that each deck will be having same number of cards, and also there are no pair of cards with the same value in the same deck. So let's say if there is a deck, then each card in that deck would be unique. So like there will be no two cards with the same number written on it. Now we are required to find the maximum possible size of the deck after buying cards and partitioning them optimally. So basically we are required to find the maximum number of size uh, which we can achieve, so that we can divide the total number of our card, so that each deck would be containing same each deck would be containing unique cards, and also each deck would be of the same size. So let's see how we can do that. uh, let's move on without an example first. Let's move to approach. Yeah, so we are solving the third problem. So let's say we have uh, we have some n cards. N cards here are there, and each each type of card, let's say ith type, is having AI cards. Now, now we are required. We are also given with k coins, and we are required to find the maximum size. Let's say s, in which we can divide our whole card, so that each deck will be containing unique unique cards, and each deck will be of the same size. Now, let's assume what would be the condition for any what would be the condition for any size s, that like if I choose any size s for the deck, uh, what let's check on the condition if it is feasible to divide whole cards in such fashion that it satisfies these two conditions. So first of all, if I assume after buying all the if after buying cards from my k coins, here also we are not required to buy all k cards, like we are not required to buy cards from using whole k coins. We can also if we required, we can use only one coin. If we are required, we can use only 2 coins. But let's say after we use coins, some of the coins, or maybe none of the coin, and the final number of cards that I am having is, let's say it is m. So first of all, it is required that m must be a multiple of s. Then only we can divide it in decks such that each deck would be of the same size. And then if I check uniqueness, then it is required that maybe there is a card of any type. Maybe there is a card of any type, say ith type, and there are AI cards of that type. And let's say AI is the maximum of all the type of cards. Let's say AI is max of A1, A2, dot AN. So if AI is the maximum of this whole array, then what we are required to do, like if AI is maximum, then each of AI cards would be divided in different decks. So if so the total number of card that I would need if I divide AI in all different decks would be AI into S. And if this number is greater than M, then it is not feasible to divide the card in size of S. And if this number is less than M, then it is also not feasible to divide this in. No, sorry. If it is less than M, then it is feasible to divide the card in size of S. Now let's see what could be the value of S. So we are given with n different types of card. So uh, n different we are given with n different type of card. So maximum value of the S could be n only, because if I say S is n plus one, then there must be one card that would be repeating. Uh, I don't know if you know pigeonhole principle, but what pigeonhole principle says, if there are n plus one pigeons and there are n holes only, then there must be a one hole that would be containing two pigeons. So if you infer from that, if I am having a deck of size S and a deck of size S, and there are only n different type of card, so there must be any one type of card that would be used in two types. So my so it satisfies that S must be below n or equal to n. So from here we can get that S must be less than equal to n or greater than equal to 1. And also now we are required to find the maximum value of S. So we can check from decreasing, we can check iteratively from n to 1. Like I would be checking, first of all, if I take s equal to n, if it is feasible, then I will take that as answer and report it. If I don't get it as answer, then I will decrement the value of s by 1, and then I will again check it. Now let's see how we will be checking it. Let's see, for any s there will be two conditions. Let's see, the maximum of the array is represented by mx. So mx into s will be the size of the will be the total number of cards that I will be requiring at minimum. Now if I see that the total number of cards that I would be having initially will be given as uh, let's say it is sum of a1 plus a2 and dot dot an, the sum of whole array. And also we are having k coins, so the total number of cards that I can have will vary from sum to sum plus k. Now we will check if mx into s is greater than sum plus k, then it is definite that we can't have the minimum quantity required for cards, so we will not take this s as answer. Now if I get my maximum of array multiplied by s is less than sum, that means that s could be the answer, but we are having some extra cards, that is sum minus mx into s. Now let's say this quantity is remaining. If this remaining quantity is divisible by s, then this s could be the answer. But if this remaining quantity is not divisible by s, then we need to increase the number of cards such that this remaining quantity get divisible by s. So we need to check if we can buy some number of cards so that this remaining quantity gets divisible by s. So checking this, we can what we can do, we can take the remainder of this remaining quantity when we will remainder when we will divide this remaining quantity from by s. So in competitive programming, remainder is represented as rem modulo s. So this will give me the remainder of remaining quantity when it is uh, divided by s. Now we need to increase the uh, quantity of the cards. So to make this remainder as divisible by s, what we need to do, we need to buy at minimum s minus remainder number of cards, s minus remainder number of cards, so that it gets divisible by s. Now this much quantity of cards I need to buy at minimum so that the whole number of cards get divisible by s. So if this required quantity is less than or equal to k, then I can say that this s could be the answer. And there will be a third condition, that this mx into s is less than or equal to sum plus k. In this condition, it is surely shown that sum plus k quantity is a quantity that could be the maximum number of cards, and mx into s is the minimum number of cards that are required to say that s is the answer for that for this problem. So if I can achieve sum plus k, then if mx into s is lesser than sum plus k, then it is definite that I can achieve mx into s quantity of cards. So I can say that this s is the answer for this problem. Now let's check it with an example. So okay, if I take an example where we are given with 5 cards and 4 coins as extra, and we are having 2 cards of first type, 6 card of second type, 1 card of third type, 4 card of fourth type, and 2 cards of fifth type. Now, if I check the maximum element from this array, then we will get mx is equal to 6. Now let's check on for s. So maximum value of s could be 5. Now checking for 5. So for 5, mx into s will be the minimum number of cards that I need, that I require at minimum, so that s could be the answer. So 6 into 5 gives me 30. And also the sum of this array is equal to 2 plus 6 plus 1 plus 4 plus 2 will give me 15. So there are 30 cards required at minimum, so that 5 could be the answer. So we are already having 15 cards, and if I add 4 cards more, that will be odd. If I use all my coins, then I can get at maximum 19 number of cards. So you can see that even I buy the maximum number of cards that I can buy, then still I can't achieve the minimum required quantity. So s equal to 5 could not be the answer. Now we decrementing the value of s will give me s equal to 4. Now checking on for 4. So 6 into 4 is equal to 24. That is the minimum required quantity for s equal to 4 to be the answer. So again you can see 24 is greater than 19. So again this could not be the answer. Now checking on for s equal to 3. 6 into 3 is equal to 18. So 18 is lesser than 19. So it is definite that if I buy only 3 card using my 3 coins, then I can get that 18 card are there, and 18 card are there, and now we can divide my whole 18 cards in 6 different decks of size 3, all with unique number. Now you would be wondering why I'm taking only maximum as in account. Why I'm not taking the other elements in account to check if that array would be having unique cards or not. If that deck would be containing unique cards or not. Let's say, let's see if I am having m number of cards and I am taking s as answer, then I would be having m divided by s number of decks. Now, say, if I consider that these are my decks, m divided by s number of decks, and if I start dividing my cards, so let's start from first. If I give it the, let's say I am having ai number of cards, uh, even number of cards of first type, and a1 is lesser than m by s, then if I start dividing somewhere in between, I will exhaust my first type. And now from here onwards, I will start dividing my second card. And as we know, for every card, we are having its like for every type of card, we are having its number lesser than m by s. So it will never be it will never repeat. Like if I start dividing second card from here, it will go on dividing like that. And if it is m by s, then it will end here. Not it will come in this deck. So it is definite that if any card is having less than m by s quantity, I can definitely divide it in a way that it won't be repeated in the same deck again. So this is how this question would be solved. And yeah, Satyam.